The topic of fertilizers is the worst answered question year after year in the paper 2 examination. And that's really sad because this is actually a very easy topic, so you should be getting easy marks. This is from the 2019 November paper. Question 10 about fertilizers was the worst answered in the paper. So let's first make sense of what's going on here in this flow diagram. And after that, let's look at the questions. But first of all, what you should do is you should download the questions from the link below, answer it all yourself, and then only continue with the movie. We can see that this involves the preparation of ammonium fertilizer. Fertilizers are, of course, for plants. Plants need nitrogen in a form they can absorb, and that form is nitrates. So this here is ammonium nitrate, NH4, NO3. So it's unsurprising that to get to that, we're going to need some nitrogen and some oxygen. So now, what exactly is the process to get from these to that, and what are the missing gaps? The first step in the production of ammonium fertilizer is what we call the Haber process. And you should be familiar with the Haber process. It's discussed under equilibrium, chemical equilibrium, because we have a reversible reaction. Can you remember what the reactants are? Nitrogen and hydrogen. And the product of the Haber process, can you see it's a synthesis reaction, combination reaction, and so we only have nitrogen and hydrogen inside this compound. What is it? Ammonia, NH3. Remind yourself about the principles of the Haber process and equilibrium by clicking on that link there. Just by the way, the catalyst that we need here is iron. Now we have ammonia. It reacts with oxygen. What are we going to get? Well, even if we can't remember, it's easy to figure out because later that reacts to form nitrogen dioxide. So the step here must have less O in than there, but it must have more O in than there because oxygen has reacted, and it is nitrogen monoxide. So nitrogen monoxide is then reacted, of course, also with oxygen, to form nitrogen dioxide. The nitrogen dioxide then reacts with water to form an acid. We're told that Q is an acid. What acid has NO in it? Nitric acid, HNO3. And then nitric acid and ammonium react with one another to form ammonium nitrate. And can you see that that's a simple combination reaction? It's extremely easy because just by eye you can see there's no balancing needed. Right, let's get to the questions. First we're asked to identify X, hydrogen, Y, nitrogen monoxide, NO, and Q, nitric acid, HNO3. Then we move on to 10.2. The first question asks about this reaction. And what is its name? What type of reaction is it? Now we can see that oxygen is being added. So it's an oxidation reaction. Not all oxidation reactions involve oxygen being added. But whenever oxygen is added, it is an oxidation reaction. To be more specific, this process is called the catalytic oxidation of ammonia. And that's because you need a catalyst for it to occur, of course. And the catalyst needed is platinum. Although it's not asked here, this entire process, which has 3 steps in it, is called the Ostwald process. The Ostwald process produces nitric acid from ammonia, oxygen, and water. And the first step in the Ostwald process is the one which needs the catalyst. the catalytic oxidation of ammonia. Then we're asked to give the balanced equation of this reaction. And as I said before, just by inspection, you can see that that's a very easy question. So we have ammonia reacting with nitric acid to form ammonium nitrate. Question 10 has to do with this information here, which is some labels on bags of fertilizer. And we see three numbers in a ratio format, a bracketed value, and then that's clearly the mass of the whole bag of fertilizer, the contents of the bag. So first of all, what is this ratio? This is the NPK value, or ratio rather. What does that mean? This gives us the mass ratio of nitrogen to phosphorus to potassium. This is by mass, not by moles. So there are 3 times as many kilograms of phosphorus as there are nitrogen, for example. Then we have these bracketed numbers, and the first question asks us about what they mean. Now these numbers tell us the percent by mass of the whole that is NP and K. So over here we have 27% of the 40 kilograms is the fertilizer. So the rest is other stuff. And here it's 21%. Next question, we're asked to find out which of these 2 bags has the most phosphorus in it. So in each case, we're trying to find out how much phosphorus is in there. That's determined by 1, what's the mass of the whole bag? 2, what fraction of that mass is fertilizer? 3, what fraction of the fertilizer within the bag is phosphorus? So that is what we have to do over here. So if I write that, which I've just said, in an equation form, well, we first need to know, well, what is the mass of the whole bag? This one is 40 kilograms. Next, we need to find out, well, what fraction of that 40 kilograms is actually fertilizer? In this case, it's 27%. And next, we need to determine, well, what fraction of that fraction is phosphorus? And this is 3 out of a total of 8. 1 plus 3 plus 4 is 8. So if we do this calculation, we'll find out how much phosphorus in bag B. Maybe we should have started with bag A. Let's do the same kind of process. So here we have 50 kilograms and 21% of it is fertilizer. And here as well as there, 3/8 of that is phosphorus. So we simply do our calculation. 50 times 21 divided by 100 times 3 divided by 8. And the answer is 3,94 kilograms of phosphorus in bag A. 4,05 kilograms phosphorus in bag B. And so clearly, bag B has more phosphorus in than A. If you enjoyed this movie, don't forget to like and to subscribe so that you can get notifications as I do more movies of this type. Also, please give me comments below how I can improve, what else you need to know, what you didn't understand, what you understood very well, whatever. And as you prepare for your exams, all the best.